All right, we'll go and get started here. So thank you guys for coming. I appreciate it. Got about half an hour here, and I appreciate the chance to chat a little bit about some of the work that we did on Forza Motorsport 7. So we're going to talk about creating some of the realistic environments for Forza Motorsport and some of the unique ways that we approach photogrammetry and laser scanning as a key part of our development process. So we'll get going. So my name is Travis Gosnell. I'm the Environment Art Director for Turn 10 Studios. Turn 10 Studios is a first-party studio within Microsoft Game Studios. We are in Redmond Town Center. So this is a kind of a quick presentation about our process, and we'll get going. If anyone's not familiar with Forza Motorsport, we're going to go and watch a quick video here, and then we're going to jump into it.
Play it on Xbox One.
So Forza Motorsport 7 was released in October. This was a Xbox One PC title. This was the first time we launched concurrently on both the Xbox and on Windows 10. So this was a big launch for us. This was our first Windows 10 game. As always, Forza Motorsport is 60 FPS, but this time we also incorporated 4K and HDR as being some of our key rendering features. And from the environment side, it's a massive game. The game has 700 cars. We've got 32 tracks. So we're talking, somewhere in the range of 180,000 art assets that are used to make up Forza Motorsport. And this is built up over the years. And so we're going to kind of talk a little bit about how we go about our approach to capturing all of that information and converting it over into the game, and hopefully give some ideas to take away about what our unique approach is. So some of the varied environments, we have everything from realistic racetracks that are, kind of the marquee tracks of the racing world. We've got one here that is Sebring International. We do wide open landscapes in cities. We have our Prague racetracks, ones that are a little bit more close-knit, a lot of high detail, a lot of high fidelity with the racetracks. And then we've got this one, which is our Dubai track. So Dubai was one of our marquee tracks for Forza Motorsport 7. Each year we try and take one of our tracks that we know we're going to have it be our IE track. And this is going to be a combination of a track that can both showcase off the game, showcase off of the new features. And particularly this year, as we were being a launch title for the Xbox One X, being able to leverage some of the power of the new system really let us push for some of our workflows and our technology in ways that we hadn't before. And so, what do I care about with environments? The two big things are the accuracy and authenticity. Forza Motorsport prides itself on being a very realistic racer. We have a huge investment in creating real-world tracks, creating real-world physics, creating real-world cars. And so that's a huge focus for us. And so when we talk about accuracy, we really want to give the player the same experience that a race car driver is going to have visiting those locations. So this is a piece of reference photography from Long Beach, and this is that same track in Forza Motorsport 7. So we are trying to recreate as close as possible down to the direction of the light, the position of the trees. It may seem like, there's flexibility with that, but when it's a racing game, those are breaking points. They're markers for the drivers as they're keeping an eye out for them. So we really double down on how to get that authenticity. This is an older video, but one that I think showcases very well. So it's from one of our community members. Some of the differences in the real world and what we get in the game. So as you can see, as it kind of drives around here, you'll see that it's very close to a one-to-one match. We're paying attention not just to the road, but to the whole environment around it. So we are trying to get all of the flags in the right places, all of the buildings are at the right scale, the tree lines are exactly where they're going to be. And so doing this across 32 environments is a huge undertaking and a huge task for the team. On the authenticity side, we're not just trying to capture that range, we're also trying to capture a lot of high fidelity detail. We want all of those details that give the character to the unique tracks. Whether they're a brand new circuit or whether they're a track that has 100 years of history, we're really looking for workflows that we can use to capture as much character and as much detail and storytelling in these environments as possible. And so we do that by really doubling down on reference. So these real world tracks are average of 4 miles long, 32 tracks, there's 120 plus miles of environments in Forza Motorsport. And so really doubling down on our reference is key. The current gen hardware, the advances that we've made with Forza Tech, with Xbox One X, has really allowed us to start bringing over data from the real world into the game engine with a fidelity that we haven't been able to before. And so for us, it's a huge important piece of our investment is really doubling down on that pre-production, doubling down on how we capture it. And so we do a lot of the standard reference photography, capturing PBR textures, but what we're going to talk about a lot today is the laser scanning and the photogrammetry. And so a quick kind of breakdown. So when we start one of these tracks, the Dubai track, which was our marquee track for Forza Motorsport 7, we start with a lot of our research. And so we're going out and we're finding the areas that are the inspiration, they are the iconic areas to that racetrack. So for us, when we went to Dubai, it was a lot of the modern cities, the modern architecture that's springing up all over the country. It's the sand dunes and the deserts, the nature creeping back over onto the reality, and it's areas that are iconic to the motorsport world. So in the bottom left there, we have the Hafit Pass. So this was a really key area for us to capture because it's on the list of greatest driving roads in the world, and we want to be able to deliver those aspirational experiences to the player. And so we start out by traveling to the locations. We do reference trips out to all of the tracks that we create for the game. Here we spent about 8 days in the UAE, and so we did a road trip across the entire country. We went with a CG supervisor, a technical artist, a concept artist, and then a couple members of the track team. So we're really trying to get representation out across the broad team when we go to capture data. We're doing a lot of standard things. We're doing reference photography, both from an in-game type of perspective, but we're also doing a lot of high-res panoramas that we're going to use to create map paintings. We're doing a lot of lighting reference. And then we're also doing a lot of our capture for our PBR system. So a lot of color correct reference, color correct photography. Here you can see a lot of these images will have the Macbeth chart in the lower right-hand corner, and so we're using that to be able to get the albedo values for all of the assets that we're going to be building in the game. And on the left side, we're doing some captures using polarizing filters to separate off the specular combination. So a lot of the imagery is key to what we do, but images aren't enough. We have found no matter how many of these that we do, you can send a whole team and spend a week there, get 10,000 images, and there's always going to be those sides that you don't get. Coverage is always going to be a problem. You're going to get back and someone's going to ask for the photo of the back side of the building, or did anyone get a picture of what's on the left side of the road here? And so finding other ways of capturing that data is important to us. Photos also miss a lot of key information. Sense of scale is a problem. You don't always have a core checker or a human in every photo that you take, so backwards engineering exactly what the scale of an object was, that's a real problem for us, and it's hard to get measurable data. We can check exposure, we can get albedo values, but getting measurable data out of photographs just has its limits. And so to address that problem, we do a lot of other things. In the past, we have done everything from wearing GPS backpacks. So for the early days of Forza, this was one of the key ways of capturing the information for the tracks. Here we would put on a backpack with a GPS transponder. We would walk the track, left side, right side, inside, outside. And so put about 12 miles in, walking all around the racetracks for the day. It's very, very accurate from a X and Y position, but it's not very accurate on the vertical. And so we needed more ways of doing that. We would go out with levels and actually measure the angle of every turn on a racetrack. We would get our tape measures and sit down and measure the width of every rumble strip, record all of this information and bring it back. But we had a data set that was a lot of numbers on a sheet, a lot of splines that we could bring back into Max, and while it gave us the information that we needed, it wasn't the most useful. So starting on Forza Motorsport 5, we moved over to laser scanning. And there's a lot of small text on this screen here, but the big takeaways are that we needed a better way of capturing that information. We needed a better way of getting better data into our system to provide more accurate racetracks coming out the other side. And so we're going to do kind of an overview of our process here and how that informs the production. So the basic overview is that we do scan capture, processing registration, a lot of view and cleanup, and then use that to feed into our production pipelines. So when we do our scan capture, we're going out on location. We've got a third-party group that works with us for most of the time. We use 2 or 3 scanners. These are Leica laser scanning systems. We're going out, setting these up. They're going to spin around, shoot out millions of little laser beams. That'll all bounce back, and what you end up with at the end of that is something that looks sort of like this. So this is a point cloud that has been processed coming back out of that capture. So this area that we're in right here is one of the metro stations in Dubai, and it's one of the really nice pieces of modern architecture that was going to feature heavily in our racetrack. So this is one of the areas that we focused on. As you can see, you can see all of the little dots down here. That is each individual points that are captured by the laser scanner. We're capturing with about 6mm accuracy, which is about 1/4 of an inch, give or take. And so this is giving us very, very accurate measurements. It's real world data that we can go in afterwards. We can grab 2 points, measure the distance between them. You don't have to depend on the number someone wrote down from a tape measure, and it's just much, much more flexible. Each scan that we do has to be registered together to create a cohesive environment. So on each one of these red dots is one of the locations that we set up our scanners. So more or less, we get about 200 meters. You can adjust for scale and time constraints as needed, but we'll spend about 3 or 4 hours at any given location like this and gather up about 8 to 10 scans. And then these scans will be stitched together, referenced together to create a cohesive environment. So once all of those scans go together, you get something that sort of looks like this, which is a large-scale cohesive environment. Once we have this data, we can do a whole lot with it. This is a short video, let's see if it'll play, in Microsoft Recap, or Microsoft Recap, Autodesk Recap. So this is a program from Autodesk for viewing and working with point clouds. And so unlike the photography, which gives a single still image, this is really allowing us to come back and anyone on the team can run around the environment. They can explore the environment in a way that we couldn't otherwise. As we have started using this data, we've started using it more and more across the team also. Once you have data that is at this level, you can also start passing it out to the other teams. The cinematic team can start doing some of their previs for their camera shots. We don't have to wait for levels to be created, for gray boxes to be created. You can immediately put it into the hands of the team, have concept artists start painting over it, have cinematics guys start working with it, and then on the art team, we start using it as the basis for our production. So for the Dubai racetrack, you can kind of see all the different areas here that were our main points that we went in laser scan. So we had our city areas, our highway areas, the Hafit Mountain Road, that was the driving road that we talked about before, the desert areas. And so from the very start, we're using this as a way of informing the production. So what we're doing here is laying out the basics of the racetrack using the laser scan data before we've done any of the work in our gray box. And so this is giving us a way of prevising what the environment is going to be at a very early stage that's also extremely informative both for the production teams and for everybody else who will be working with it. What you're looking at here is a render from 3D Studio Max, so this is just a viewport render. You can see the mesh that's laid along the ground there is representative of where the racetrack is going to be. That's our very first collision that we're laying down to race. So at this point, we're doing our very first work to get it playable in the game, but you can already pre-visit as something that is both aspirational for where we're headed and very representative of what steps need to happen to get us there. We talk about the authenticity and letting players drive the locations. A track like this is made up of multiple scans, and each one of those may be aspirational for the area that we're playing, but when you're in any of those areas, it's still very important to us that if you're driving the Hafit Road portion of the track, you are literally driving that road, right? Every turn is going to be laid out as that turn exists in real life. And the scan data lets us take those areas that we've captured, look at them from a large scale, and start placing them together in a way to recreate these environments. The other thing that we can do from it is start breaking up that laser scan data in a way to inform the actual production. So instead of going through just 10,000 reference photos and trying to pick out what are all of the unique assets, we can fly around the environments and actually start picking out the assets that really matter. Which ones are breaking up silhouette, which ones are close to the track. Start creating our asset manifests in a way that will inform the production and really speed up the production for us. At that point, we can start isolating the scan data for each one of the assets, and that will go off into its own max file that'll then go off to a 3D artist to build. But at that point, they have reference that is already it's captured with real world scale, they've got the color correct photography to go along with it, they've got all of the physically based material reference, and so they've got a package that's ready to go for the creation of an asset that can really streamline production in a big way. That same metro station that we were talking about, this is it with the scan data converted over into 3D Studio Max. And you can see that it's then used to model directly on top of. So a modeler can go in and instead of trying to put two planes up, look at where the images are and try and figure out the exact scale of this thing, they can fly around it in 3D and use it as really an organic piece of reference to inform their work. And then from there it goes over into our game. This is a quick image of Fuel, which is our proprietary engine, and this is where we apply all the PBR materials to it. So it's a very easy translation from the initial scan data across into our game engine. From there we can take an overview of that scan and take all of the different areas. This is one of the large images for the Hafit Pass, so you can see again, just like we collected all of those scans for the first area, this was a set of about 30 scans that were collected going up and down this road that have been stitched together that give us that 3D representation. And so when we are making objects like the metro station, it's relatively easy to go through, sign it out to an artist. We're doing a lot of kind of meat and potatoes, hard surface modeling. When we get to all of the organics around the terrain, that's where it's a new challenge for us. And we can use a lot of traditional terrain technologies, right? We can use our world machines, we can use our views, we can use our Houdini terrain engines, but we're also trying to be true to the authenticity and the accuracy of these locations. And so for us, really doubling down on the photogrammetry was a big piece of that. And so we will start with a simple gray box, and that's just blocked out by hand from the laser scan data. And this is informing us where we're going to start breaking down that photogrammetry. And from there, we're going to start replacing that with our final in-game assets that's generated off of the photography that we took on site. And so if anyone's not familiar with photogrammetry, the quick overview is that photogrammetry is made up of taking a whole lots of photos of a real world object, then using software, we use a combination of Agisoft Photoscan and Reality Capture to calculate all of the trajectories off of those images and figure out how you would recreate a 3D mesh off of those. So while we were on site, we take an absolute ton of photos. Everything from all of the rocks to the large scale mountains, and we're going to come back to the studio and process that, and now we're going to get a lot of the data that we're going to use to repopulate the world. When we're breaking it out off of the environment, we sort of break it up into a couple of main areas. For us, it is kind of broken off into large scale environment set pieces. So these are large scale elements of photogrammetry. We're breaking it off into kind of the surface materials, so ground materials, ones that are going to inform the standard terrain piece of it, and then kit bashable materials, you know, simple rocks, scree piles, things that can be scattered around the environment to do a lot of the set dressing. From there, we're going to take all of the images of each one of those assets. The workflow is relatively straightforward for the artist at this point. It's a lot of meat and potatoes, retopology. We're using a combination of either retopologizing in 3D Studio Max for relatively simple assets, or taking it into ZBrush for other assets. And so this is where we'll go in, we'll chop out the elements that we captured. In a lot of cases, there's elements like the bottom of it is going to be missing. The artist will go in, a lot of kind of bespoke modeling work to fill in those elements. But then what they're left with at the end is a very reusable asset that we can start making these sets to use around the environment. and it's letting us capture a lot of fidelity in ways that we just couldn't before. So just like the laser scan allows us to get that accuracy for our environments, the photogrammetry is a key piece for how we get the fidelity into all of these pieces. So we are going through, we're capturing everything from road edges, large-scale environment pieces. Here's some examples of some of the terrain materials, so feeding into our terrain system. We use a combination of substance, either to regenerate substance versions of the materials, or as a processing stage to capture the photogrammetry materials, run it through substance, and then create tileable PBR materials out of that. From there, all of that gets brought back into our engine, and so this is one of the materials that was brought from our photogrammetry and created into a final PBR engine material that is rendered inside of our engine. And so this, as an art director, is hugely inspiring because it lets me go around and choose the assets that were captured at the reference trip and really pick out the ones that are both reusable and define the overall character of the environment, but also the ones that are very bespoke and add a lot of the visual interest and can give character to individual areas. And what we're left with at the end is something that is really representative of that initial photography for it. So we've got some of the large-scale photogrammetry that we're using to create that area, and then at the bottom you've got the GIF there of what it looks like inside the final of Forza 7. And we've got some of the final images from the track. So this is the game running on the Xbox One X. Photogrammetry on the Hafit Pass. And that's what I've got. So thank you all for watching. I appreciate it, and hopefully you've got some ideas for how you can leverage some of those elements to kind of feed into your production and really inform how to streamline your production and get real world values. Thank you very much. Appreciate it.